Hey, how's it going? We already learned how to interpret the coefficients of the PD model and how to estimate the probability of default and, respectively, the probability of non-default of individual accounts. And as you can recall, we did it by applying the predict method to the test dataset. Let's quickly revise how it's done. First, we should multiply the values of a borrower on the independent dummy variables by the respective model coefficients. So when an exponent is raised on this result, it equals the odds for being good versus bad. From there, you can easily calculate the estimated probability of being good. Now, each observation from all dummy categories of the original independent variable can only have a value of 1 for one of the dummy variables. The rest are always 0. So we don't need to bother multiplying at all. Let me explain why. Multiplying by 0 is always 0, and multiplying by 1 yields the same result. So calculating the power on which the exponent should be raised to obtain the odds boils down to the following to summing the regression coefficients for all dummy categories to which an observation belongs. It's time to check out how it's done with a practical example. We'll use the Inputs Test with Reference Categories data frame. Let's take the first observation from this dataset. Its index is 362514. First, we take the intercept. It's minus 1.338497. Then the external grade of this observation is C. We add its respective coefficient, or 0.689618, to the intercept to get minus 0.648879. Next, we look into home ownership status. As you can see, the borrower has a mortgage. The coefficient of that dummy is 0.106222. So when we add it to the total up to now, we get minus 0.542657. According to the data, the borrower lives in California, so we can add the coefficient for California, or 0.064466, and get minus 0.478191. What's the borrower's verification status? Verified. But there is no coefficient for this verification status because we used it as a reference category. Hence, we add 0. The total remains unchanged. Okay, let's continue. The purpose of the loan is either major purchase or car or home improvement, and the coefficient for that dummy variable is 0.265831. If we add it to the total, we'll get minus 0.21236. And we can go on until we've added all the relevant coefficients to get a final sum of 2.50279. These are the log odds. Let's get rid of the logarithm. As we discussed already, to achieve that, we raise an exponent to that power. The result is 12.216531. In conclusion, the estimated probability of being a good borrower is equal to this number divided by that same number plus 1, or 12.216531, divided by 13.216531. And it's exactly 0.924337. Therefore, the probability that this person will not default is 92.43%. Similarly, we can calculate the probability of default of each new customer. What is done in practice, though, is a bit different. Banks usually turn these models into scorecards. Scorecards have the advantage of being standardized. No matter the model, the scorecards look the same way. This makes them much more interpretable for non-technical people and allows us to compare different PD models. In the next lecture, we'll do just that. We are going to turn the PD model into a scorecard and learn how to calculate the credit score of each borrower. Thanks for watching.